Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Tashri bin Zakaria from LO1 P3. So for the assignment, I'm from the group 6. So I will be explaining for the question 1, which determine the voltage and current for the R5 resistor by using Norton theorem. Okay, this is the question which determine the voltage and current at R5 resistor. This one is R5 resistor, so we need to find the voltage and the current for this resistor using the Norton theorem. Okay, for step 1, we need to redraw back the circuit. Make the circuit shortcut for R5 resistor. Then we find the I Norton. To find the I Norton, we need to know where the current flow. So for this circuit, the current will not flow through the R6 and R7 because the current will flow through the easiest way without the resistance. So we know that the current flow from R4 to the I Norton, so I the short circuit. So in this one, the current flow in series way. So in series, we know that the current is the same. So IN is equal to the IR4. So to find IR4, we use the CDR formula, current divided rule formula, which is R total divided by R4 times the I total. Okay, to find the I total, we use the Ohm's law, VIR, which means I total is equal to the V total divided by R total. So V total is 5 volt, then we need to find the R total. R total is R4 is in parallel with the R2 and R3, then we plus the R1. So for R4, 10 ohm, parallel for this one, 12 ohm, 4 and 8, and then we pass the R1 4 ohm. Then we got the 9.5 ohm. The one is for the R total. So we know that I total 5 volt divided by 9.45 ohm. Then we got the 0.529 ampere for the I total. Then we just insert into the formula this one. So for the CDR R total is for this one. So R2 plus R3 divided by R4 plus this one, R2 and R3 times the I total, 0.529. So we got the I Norton 0.288 ampere. So the step 2, we need to find the Rn. So we need to redraw back the diagram. So for the V source, we make it into the short circuit. And this one, we need to find the Rn. So to find the Rn, we need to see from this side. So R1 is in parallel with this one, R2 and R3. Then we add up to the R4. Then we make sure this one is include also. So this total will parallel to R6 and R7. So 30 ohm, the total for this one is parallel to these two, 4 ohm. So we find the Rn and 3.06 ohm. Okay, for the last step, step 3, we need to redraw back the diagram into the Norton diagram, which the source is in current. So for the source, we use the IN 0.288 ampere and Rn 3.06 ohm, and the RL, which means the R5 from before, which is 4 ohm. Okay, to find the IRL, we use the CDR formula, which R total divided by the RL times the I Norton. So RL we have 4 ohm, and I Norton we also have 0.288 ampere, but we need to find the R total for these two, Rn and RL. So we just use the formula in parallel. So we got the 1.73 ohm. Okay, we got the R total, then we just insert into the formula, then we find the answer for IRL, 0.125 ampere. So we got the current for this one, RL. So then we need to find the voltage for RL. So we just use this Ohm's law, which is VIR. So 0.125 ampere times by the 4 ohm. Then we got 0.5 volt.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Najmi bin Amran. I'm from LO1P3 from Group 6 also. Okay, I hope you, Madam, and Muhammad Yusuf in a good condition. Okay, today we have seen that Tashrif have done it, the calculation in a manual way, and now I will be doing the calculation in using technology by using software for the simulation. From the simulation app software, we got the current is 1.25 milliampere and the voltage is 500 millivolt. This is the exactly same as the Tashrif calculation by using manual method. Okay, thank you.
Assalamualaikum and good morning. My name is Muhammad Nazmi bin Muhammad Bukhari from LO1P3 Group 6. Today I will explain for equation 2 by using Thevenin theorem. The question is calculate the current and the voltage through R5. Step 1, we want to calculate the I total. First, R2 is a series with R3 and we get 16 ohms. R23 is a parallel with R1 and we get 5.33 ohms. For the I total, we use Ohm's law formula Vt over Rt and we get 4.5 ampere. Step 2, we want to calculate the RTH, and first R23 is a parallel, R2 is parallel with R3 and we get 3.75 ohms. And for our total, R23 is series with R4 and we get 11.75 ohms, which our total RTH is 11.75 ohms. Step 3, we want to calculate the current load and voltage load. And for the current load, we use the formula VTH over RTH plus RL. For VTH is 15 over 11.75 plus 4 and we get 0.95238 ampere, which is a current load. For the voltage load, we use Ohm's law and we get 3.81 volt. That's all. Thank you.
And now I will continue with Nazmi discussion about the Thevenin equation. Okay, Nazmi, from the calculation he has made, Nazmi has calculated the I load, which is 0.95238 ampere, and for V load is 3.81 volt. Okay, for me, who is in charge for the simulation, I will now compare the answer which he has made with my simulation.
Okay, now we have looked to the simulation that I have made. So the question is calculate the current and voltage through R5. So R5 is over here. Okay, so from the simulation we know the answer is for the I equal to 952.38 milliampere, which is exactly same as Nazmi calculation. And for the volt also 3.81 volt, and it was exactly as Nazmi has calculated. So it was concluded that the calculation and the simulation are true.